Alright, so this is the free fall problem, and what I've been given is hanging out of the window of a tower at a height of 225 meters. A physics student uses a cannon to fire a steel ball upward with a speed of 20 meters per second. His lab partner, standing on top of the tower at a height of 320 meters, drops a bowling ball at the same instant. So here is my dope picture. Here is physics student. We'll label him physics student physics student 2. Physics student 1, 2, and this will be student 1. Alright, and so he is firing this ball with a handheld cannon, whatever you want to call it, with an upward velocity of 20 meters per second. And the first question we're asked is, when are the balls at the same height? So I can use, for physics student 1, I can use the formula y1, that's just representing him, is equal to, that's his, it's not representing him, it's his, upward, his, like, height in the up direction. So y1, vertical height, is equal to 1/2 gt squared plus v0t plus the initial vertical height. And then we can plug and chug some numbers in here. Y1 is equal to 1/2 gt squared plus his initial velocity was 20, so 20t plus his initial height, which was 225, so 225. And then that's our formula for the first physics student. And then the second physics student, who's standing on top of the cliff, his equation would look something like this, just the same with different numbers. So y is 1/2 gt squared plus v0t plus 320. This v0t is just going to be 0t because his initial velocity is in fact 0, so it's just 0t. But I'm just going to write as v0t. And then since I know that y2 is going to be equal to y1 when they hit the ground, I can set these two equal to each other. So 1/2 gt squared plus v0t plus 320 is equal to 1/2 gt squared plus 20t plus 225. And then 1/2 gt squared on both sides can cancel out. And then you're left with 320, and that v0t cancels out because it's just 0t. So 320 is equal to 20t plus 225. 225, subtract 225 from both sides. 20t is equal to 95. Divide by 20 on both sides. T is equal to 4.75 seconds. So that's the answer to the first question. There's my work. All right, and now the second question is, what we're asked is, when do the balls have the same speed? Show your work. So, first one, let's draw some lines here. When do the balls have the same speed? Sure works. So, V1 is equal to GT plus V0. And what this question is asking is for the speed, not for the velocity. So, just bear with me here for a minute. So, I'll explain it. V1 is equal to GT plus V0. So, I'm writing out the velocity formula for kid 1, for person 1, for physics student 1. And V1 is equal to negative 10t plus 20. And for student 2, his GT plus V0, V2 is equal to negative 10t, because that V0 is just 0. His initial velocity is 0. So we'd just be left with negative 10t, and for gravity, or gravitational field strength, gravitational field strength, it's negative 10. So negative 10. Or it's, yeah, it's the value is negative 10. Things fall to the earth at negative 10 meters per second. Just negative 10 meters per second. So negative 10, that's what I'm plugging in for G. And so speed, this is where those formulas come into play. Speed is equal to the absolute value of velocity. And so, using the same formulas that these two formulas, I can say that negative 10t plus 20 is equal to the absolute value of negative 10t. So what happens to the negative 10t is it becomes positive. So we're left with negative 10t plus 20 is equal to 10t, not negative 10t. And if we were to set these equal to each other like so, like this, you would get negative, you'd get 0 is equal to 20, and that's not right. It's not right. 0 doesn't equal 20. So you have to know that speed is equal to the absolute value. And so when you apply that to this equation, you actually are able to get an answer that you add 10 to both sides. 20 is equal to 20t. T is equal to 1 second. And just to confirm this answer, you can make a graph, or a t-chart, sorry. A t-chart with time and velocity 1 and velocity 2. And if you go up, so say, since we think it's 1 second, to confirm that, we're going to go maybe just up to 2, because we don't need anything else. But up to 2 seconds at time 0 for student 1 who's throwing his ball up at 20 meters per second, his initial velocity is 20. For V2, it's 0. And then at 1 second, this has lost 10 meters per second because the Earth is pulling it down with 10 meters per second. So it's negative. So what's 20 plus negative 10? It's 10. What's 0 plus or just 0 minus 10? It's negative 10. And then at 2 seconds, it's 0. And at velocity 2, at 2 seconds, it's negative 20. And right there, at 1 second, it's had negative 10. They're traveling at the same speed. Same speed. So we can confirm that this answer that we got mathematically is correct because of a t-chart that we could just make as well. So for when do the balls have the same speed, it's at time is equal to 1 second. All right, and the last question is, which ball hits the ground first? So what I can do is I can say y1 is equal to v. y1 is equal to, sorry, goddammit. Just read my work wrong. y1 does not equal v. That doesn't make sense. y1 is equal to 0. So since that initial or height is equal to 0 because it's hitting the ground, what I can say is 0 is equal to, it's just that, 1/2 gt squared plus v0t plus 225, that formula, right? And then 0 is equal to negative 5t squared plus 20t plus 225. That's just if you want to know, it's y0, the initial height. And this negative 5t is, you know, what's half of negative 10? It's negative 5t squared. And the initial velocity was 20t, or was 20. And then, you know, you multiply t, the variable. So, and then you can just factor this answer. So, or just factor this. So, you get 0 is equal to t plus 5, t plus 5, and t minus 9, and time can't be negative, the last I've heard, so t is equal to 9 seconds. And that's for ball, for this guy right here who's throwing it at 225. And we need to find it for the second guy, because he's going to have a different time. And it's the same thing as this side. It's, you know, y2 is equal to 0 because it's going to hit the ground at the end. And it's asking which ball hits the ground first. So at that final, at the final spot, y2, at the final vertical height, it's 0 because it's hitting, the ball is hitting the ground. If it were y0, you know, the y sub 0, it would be just referring to the initial height. So for this ball, it would be 225. For this ball, it would be 320. But if it's the final, which it is here, it's 0. So 0 is equal to negative 5t squared, just the same formula as this one, just with different, you're just plugging and chugging different numbers in because of the situation that the person is in. So negative 5t squared plus 0t plus 320, and then add 5t to both, well, add 5t to both sides, so you can get a variable by itself. 5t squared is equal to 320, sorry, 5t squared is equal to 320, divide by 5 to both sides. T squared is equal to 64. What is the square root of 64? But 8. T is equal to 8 seconds. And so which ball does the ground, or which ball hits the ground first? It's going to be this one right here. T is equal to 8 seconds, ball 2. So that is ball 2. And Bob is your uncle. All right. Thank you very much. Have a good day. That's it.